गम है ज़माने में मोहब्बत के सिवा. So we have x1 prime is equal to 25. He is consuming again 25 units. So I have to define why we have this peculiar thing. So x2 will be 2 times x1. x2 double prime will be equal to 50. Okay. Now when we have given him extra 50 units of income, consumer is again demanding only 25 units of good x1 and 50 units of good x2. Okay, so our new budget, the third indifference curve will be what I can say, what we collinear to the initial budget. That will be collinear to this indifference curve. That means if here we have IC1, so IC1 is equal to IC2 again. Rather IC3, if I write it here IC3, because IC2 is this. Now why it has happened here? Simple thing. If we have the Cobb-Douglas utility function, so our indifference curve could have been like this here. Okay, then the movement from this to this we would have called it the substitution effect. But since we have the perfect complementary utility function, so we can say consumer consumes the things in the proportionate order, so substitution effect will be here 0. Okay, that means what will be the substitution effect in this case? In this case, so here this was our x1, this was x1, this was x2, this was x1 prime, this was our x1 double prime. Okay, so what is substitution effect here? Substitution effect is x1 double prime minus x1, that is equal to 25 minus 25, which is equal to 0. So there is no substitution effect in case of perfect complementars. Remember this thing, because we demand the things in a fixed proportion here. That is why if the price of good has changed, quantity of that very good will remain same because of the fixed proportionality. Okay, up to this it is perfectly okay. Our substitution effect is 25 minus 25, which is equal to 0. Now we need to find out the income effect. Okay, what will be the income effect? Let us denote by income effect will be equal to so from this to this, it denotes the income effect. Okay, so income effect will be equal to 20 minus 25, which comes out to be minus 5. So income effect will be equal to minus 5. That means quantity demanded of good x1 will decrease by 5 units because of the increase in the price of good x1. Now we also need to find out the ordinary income effect. So what is meant by ordinary? We have to find out the endowment effect here. Endowment effect. By endowment effect, what we mean? How much quantity of good x1 will the consumer consume when the price of endowment has changed. Okay, so to find out the endowment effect, we need to see how much there is change in the endowment income of the consumer. So let us denote by del m, that was prime, double prime. Change in the endowment of the consumer will be equal to, endowment income will be equal to, that will be equal to the change in the price, that is del p, change in the price times the initial endowment, that is equal to change in the price is 2, because endowment is again 70, so it is equal to 140. 2 into 70, which comes out to be 140. Now what will be the new income of the consumer? New income of, let us denote by S double prime, it will be equal to initial income plus the change in the endowment income, that is equal to, obviously when the price of good increases, his endowment income has increased because its price has increased. So this is equal to 200 plus 140, it comes out to be Zat Saji Parishani Rusti. Okay, so his income as in endowment income is equal to 240. Now what we need to do? We need to find out the endowment income effect also. For that, what I need to do, so let me wrap this. This has nothing to do with this Cobb-Douglas thing. Okay. B. So we need to find out the optimal consumption bundle when the endowment income has changed. Again, we will maximize U is equal to 2x1 comma x2 such that, now what is the price? We need to find out the endowment budget line also. Why do I write it? So let me write it here. So now we need to find out the another final budget line, FINAL, final budget line. What will be the final budget line? That will be equal to price of good 1, that has changed. Price of good 2 has remained same, but endowment income, that I do not write, M double prime has changed. Okay, so consumer will try to maximize U is equal to minimum of 2x1 comma x2 such that his new will be this is 2x1 plus 3x2 will be equal to 240. Sorry, it is here 140, yet it's 240. Okay, again using the equilibrium condition, and let me see buchusai videos muskin bulch nasan. Okay, it is within the limit. Af nazar be bon sab visible win. No, I am not. So I have to stop here. So again using the what we call the equilibrium condition, that is we equate maximize this such that this stuff. So we equate x1 with 2x1, whatever is x1 is equal to 2x2. So plug, sorry, 2x1 is equal to x2. Okay, for optimality we know 2x1 kaiti get. Okay, let's write for optimality. We know I will write it here. So we equate 2x1 is equal to x2, plug value here. So we will get 2x1 plus 3 in place of x2. We have 2x1 is equal to 240. So this becomes 2x1 plus 3 to the 6, x1 is equal to 240. So shut us get 8x1. Am I doing it correctly or not? No, it will be. Income has changed. Income is 4. Okay, income has changed. So we have 4x1 plus 3x2 is equal to 240. So plug 4x1 plus 3 in place of x1, x2 we have 2x1 is equal to 240. So 4x1 plus 6x1 is equal to 240. So it is 340 here. Okay, sorry for my horrendous mistake. Okay, so it is 10x1 is equal to 340. Dividing both sides by 10, we get x1 triple prime will be equal to, so let me write it here. So x1 triple prime will be equal to 10. Okay, he will consume Nara logos be Nara Yash 34. Well, I divide karbo. So he will consume 34 units of good x1, and x2 will be equal to the double of x2. That is so it will share, so it will be 68. Okay. Now with the change in the endowment income of the consumer will consume 34 units of good x1 and 68 units of good x2. Now what is then the endowment effect? So